Dear boys, in previous classes we were discussing about the solids and fluids along with their properties. Here we are going to look into the various kind of stresses acting on simple as well as compound bars. In the mechanics of materials, the stresses in simple and compound bars are crucial concepts when studying the deformation and behavior of the material subjected to various loads. It means that we are applying various kind of loads. It might be a point load, it might be uniformly distributed load, it might be uniformly varying load. Depending upon the application, we are applying the loads on the material. Here we are going to see the stresses in simple bars as well as the stresses in compound bars. Let us see the stresses in simple bars first. A simple bar is one that consists of single material and its cross-sectional area remains constant throughout its length. Simple bar is one that consists of a single material and its cross-sectional area remains constant throughout its length, whatever may be the length. The stresses in a simple bar is defined as the force applied divided by the cross-sectional area. That is, sigma is equal to Fa. That is, the stresses in a simple bar is defined as the force applied divided by cross-sectional area. That is, sigma is equal to F by A, force by area. We can mention sometimes the F instead of S, we may mention it as P. P is the pressure. Pressure. Sometimes we are knowing we are saying that as pressure, and here we are saying that force. We can mention this as P by E. Okay. Um, Sigma can be mentioned in the unit as Newton per millimeter square. Yeah, here F is the applied force in newtons. A is the cross-sectional area of the material. Stress is typically expressed in pascals. Pascal is Newton per square meter. Tensile stress. If the force is pulling the bar apart, the stress is known as tensile stress. When the force is pulling the bar apart, the stress is known as tensile stress. If the force is pushing the bar together, stress is known as compressive stress. Example for simple bar. Consider a steel bar with the cross-sectional area, that is A is equal to 10 millimeter square, which is subjected to a tensile force of 2000 Newton. The tensile stress is P by A, pressure applied by the area. Here we have to do the calculations. Okay. Then stresses in compound bars. A compound bar is one that is made up of two or more materials, typically joined end to end or side by side. Each section of the compound bar may experience different stresses based on the material properties and the applied force. Type of compound bars are series in connection and parallel in connection. Two materials are connected end to end in such a way that carry the same force parallelly side by side. Stresses in compound bar. If a compound bar is subjected to force, the individual stresses in each section are determined by the force. The cross-sectional area of each material and the Young's modulus can be calculated. The total force is same across all the sections, but each material will experience a different stress depending upon its properties. With this, let us concluding today's topic. Thank you.